Hi guys, welcome back for the video. This video's topic is going to be queue. Okay, and this is the fifth video in my data structure and algorithms course. Okay, so let's start with the topic. So here are some points about queue. Okay, so a queue is a data structure that provides temporary storage of data in such a way that the element stored first will be retrieved first. So this line over here is really important because it defines the whole purpose of it. So the second point is this method is also called FIFO, which is first in first out. Okay. So what's all this? Okay. Let me elaborate. So let's assume with an example. So in real life, we can think of a queue as a queue of vehicles. Okay. A queue of vehicles waiting at a petrol pump. People waiting at the bus stop for the bus. The first person to enter the queue is the first person to leave the queue. Means like if you are, let's assume a hypothetical situation in which you are in a line to get your notebooks checked, okay, as a student. So the first person who got into the queue, okay, will get the notebooks checked first. So he will be the first one to leave the queue, okay, and the last one person who joined the queue will be the last person to leave the queue. So this is just opposite of what's a stack, okay. So uh, I assume that you got the idea, which means, and this method is for first in first out. Means the first person who got in the queue or first element will also be the first element to get retrieved from the queue. Okay. So let's go to some important functions. Okay. So the first function is in queue. So what's in queue? Let me change the color. So in queue is a function that means that we're adding an element to the queue. Okay, we're adding it to the last uh, to the rear part of the queue. Okay, and dq is a function which means that to remove the first element from the queue. Okay, from the front. So these are two important functions. We're going to see this in a practical C program also. So here you saw that there are in queue and dequeue. You can also see the rear part and the front part, which means the front part is the first element which got into the queue and the rear part is the last element which got into the queue. Okay, so we're going to use some functions to create a situation in which we can use the queue. So the first two are going to be the enqueue and dequeue, and then we're going to create a function about how to check the front element in the queue and the rear element of the queue. Then we're going to use the standard library. It's just like how we STL library. Okay, I'm going to use that. It's just like how we implemented a stack in which the last element got into the stack was the first element to get retrieved. So it's quite the opposite of a stack. It's an STL library. So this follows an STL library and which we use a function called malloc. Okay, so what this malloc function does? So it basically allocates some memory for our uh, data structure, okay, which is queue. So I used it in the previous lecture in which we discussed about stack, but let me make this clear that malloc function is really important, okay, when we are working with uh, data structure. Okay, so standard library is a must if we are working with data structures and algorithms. So now let's go into the C program. So let me open my source code editor, which is Sublime Text. So let's check. As I told, we have included the standard library, and first of all we're going to create the skeleton of queue. We're going to create a structure in which we created the first element is there, the rear element is there, and the size of the queue is there, in which the capacity is unsigned and we are implementing it using an array. You can also implement it using an linked list as we talked in the stack data structure. So you can experiment, but here we are keeping things simple by using the array. So to create a queue, first we have to like allocate some memory to the queue. So I told you that this malloc function is creating some memory for our queue. Okay, so size of the structure queue. So now we are going to traverse the capacity, okay, which was passed as a parameter over here. Then we're going to traverse to the front part, which gives us the size 0. So this is the recursion part, and then we're going to return the queue. So this is the create function over here. So let's check the is full function, in which I'm going to pass the queue as the parameter and then return the queue size. That queue size is equal to the queue's capacity, means how much capacity we have assigned to this queue is matched by when we like uh, check the size of the queue. So this is the recursive algorithm for our is full function. So important part is that we have the enqueue function, which is to add an item to the queue, to the rare part of the queue. So this recursive algorithm will add an element to the rear side of the queue. So here is an is empty function which will return if the queue size is equal to 0. Okay. So here is the dequeue function in which we will remove the front element of the queue. Okay. So this is the recursive algorithm for that, and then we are going to return the item, whichever item was dequeued. So now we have the front uh, function which will check the uh, which will return the first uh, element in the queue. Okay, so as we are using the array, okay, so now we are returning the first part of the queue, and here is the rear function in which we will retrieve the rear element of the queue. Okay, so we are using the array also here, in which we are getting the traversing to the rear element of the array or queue. Okay, so here we have the main function. Okay, so first of all we created our we allotted some memory allocations, okay, using the create queue function which we created earlier. So now we include some value in the queue. The first is 10 and vice versa. Then what we did, we dequeued a value from the queue. So what will be the value will be dequeued from the queue. Okay, so it is going to be 10. As I explained earlier the first element which was added to the queue will also be the first element to get retrieved. Okay, so it will show that 10 was the element which got dequeued, and then we added some more elements to this queue, and then we'll check that what is the front element in the queue and what is the rear element of the queue. So if we dequeue the value 10, then the front element is going to be 20 and the rear element is going to be 40. So let's run our program in the terminal to check if all we did was correct or not. So we open the terminal over here. So let's compile this file over here. Q. Wait a second. Q. P. So our program is now compiled. So now let's run the exe. So as I told that the we include 10, 20 and 30 and 40 elements, these elements to the queue. Okay, we include means we added them to the queue. So the first element which got added was 10. Okay, and then we dequeued a value from here. So the first element which got added was 10, and then the first element which got retrieved was 10 also. So then we check the front item, which was 20 over here, because we dequeued 10, and the rear item was 40 because it was the last item which got added to the queue. So yeah, I think this was it for the video, and I'll see you next time. Bye.